Good morning, students. I am Dr. P. Pichemanikam from Department of Computational Intelligence, Saram Institute of Science and Technology. Today's session we are going to discuss about the DQ. So, what do you mean by DQ? Last session we have discussed on the queue process. What do you mean by queue? What are all the operations of queue? So, how we are going to implement the queue in the two different operation, NQ operation and DQ operation. So we will discuss with the DQ. This DQ is a double-ended. First one thing is DQ is a double-ended structure. So before going to this, I will explain this the data structure of the queue. Queue is a data structure that enforces or that implements the first come first serve. Who is coming first? That should be processed, and that's the order that should be processed. So this is a very waiting line. This is a very waiting line. This is a very real time. Very good real-time example of this queue. So all of you are knowing on that. For getting tickets or getting meals in the hotel or verification of the documents or anything else, we are forming a queue and to process all those aspects. So here the double-ended queue. So the double-ended queue means what is this? Here the elements can be added or removed at their end only. So here we are having the both the ends. Both the ends may have the insertion and deletion can be performed in the both the ends also. So the previous case, the front end that should is responsible for the deletion process, and the back operator, rear operator that is responsible for adding the element into the queue. But here this is a queue. We are having the both ends. The both ends that is responsible for inserting or deleting an element. Okay, so insertion and deletion there should be is called as a double-ended queue. So we are going to discuss. So what are all the properties of queue? So here the double-ended queue that can perform both the insertion and deletion operations. So based on the last in first out principle. So this is an insert we are going to discuss. There is 2, 12, 7, and 3. So last in first out principle for the insertion and deletion process. Another one more thing is, so what are all the properties of the DQ? So the DQ can perform the insertion and deletion and principles of the first in first out principle. So here we are maintaining the DQ and NQ process. So then the Q may have the set of elements. Suppose the NQ means we just insert an element at the back with the help of this the rear pointer. Suppose deletion process, we just inserted the front element of the first element of the front. So this is a DQ process, NQ and DQ process. So what are all the types of DQ? So here we are having the two different types. One is an input restricted DQ. Another one more thing is output restricted DQ. So these two things we are going to discuss. So input restricted DQ means what is this? Here it is a DQ that has some certain restrictions for inserting an element. Okay, so here what is the thing here? The insertion, that is the elements can be inserted from one end, and the elements can be removed from both the ends. So input means input is can be considered as only one end, but the deletion there should be can be removed. Sorry, the elements can be removed at both the ends also. So output restricted DQ. So what about the output restricted DQ? So it is a DQ that has or the constraint. There has some certain constraints or restrictions for removing an element from the queue. So here the elements can be removed from the out one end. The elements can be inserted at both ends. Okay, so these two things that should be considered. So the elements can be inserted, or the elements can be removed from the end, and the elements can be inserted at both the ends. Okay, so that should be considered. This is a representation of this. The pictorial representation of this output restricted queue. So the basic operation that performed that can be performed on the DQR. One is an insertion at the front, insertion at the rear, and deletion at the front and deletion at the rear. Okay, so this is an insertion at the front. So here initially we are having the value as insert for front and rear points the same value. Here the insertion takes place at the front. That is front means definitely and that is we just doing the insertion at the front, so moving towards the front of it. Okay, so this is an example. Okay, so after that, what is the code for this? So how we are, what is the routine we are going to use? So we just check, and if the front value is equal to 0 means so the element is present in the front. Suppose else it means what is the front is equal to minus 1. So front is equal to front plus 1 and rear is equal to rear plus 1, and we just increment assign the value on the DQ operation. So DQ of front is equal to x. Suppose if the condition is false, so front is equal to front minus 1 and DQ of front is equal to x. So this is the routine to insert an element in the front end. So insertion at the rear side. So back side means what is the back? So we need to insert an element at the back. So 10, 20, 30 we are doing at the back also. So routine to insert an element at the rear end. So what we are going to do is first we need to check the behavior of the Q. So rear is equal to array size minus 1. If it is there, there is error is equal to full Q. Suppose else if means that there is rear is equal to minus 1. So front is equal to front plus 1 and rear is equal to rear plus 1. So DQ of rear is equal to x. So this is an x. And else means the rear is equal to rear plus 1 and DQ of rear is equal to x. So this is a routine to insert an element at the rear. So delete at the front. So front means so initially we are having the key values f is equal to minus 1, r is equal to minus 1. So f is equal to 0 or r is equal to 4 also. So q is empty. And actually DQ format. So this is the way we are deleting the element from the front. So what is the code we are going to follow this one? That is if front equal to minus 1, that is empty q. Or otherwise, if both the front and rear q are same, that is x is equal to dq of front is equal to minus 1, rear is equal to minus 1, or else x is equal to dq of front is equal to front plus 1 also. So this is the why delete front. And the front had deleted the rear. So deleted the rear means what is it? Here some we need to delete the element at the rear side. So this is a possibility we are doing this. And so what is the code we are going to follow this? So why delete DQ of rear? That is if rear value is equal to minus 1 MDQ. Suppose it is not there. So else if front is equal to rear. So x is equal to DQ of rear. And the front is equal to minus 1. The rear is equal to minus 1. Else means x is equal to rear DQ of rear. And rear is equal to rear minus 1. So this is the routine to delete an element from rear end. So next one thing is application. So what are all the applications of DQ? There are two different applications we are using. First one is polyandrome checker. So what is the use of this one? That is rear front, that is the radar. Okay, suppose so we need to add to the rear as well as the front also. So we need to add the elements or add the characters at the rear side, or we have to remove the character from rear, and here is also we just remove from the front also. So we can do that. So this is one aspect. Another one more thing is the job scheduling algorithm. So job scheduling algorithm is one of the important aspect of this and the DQ process. So still algorithm impacts on the task scheduling for the several process. So here the first the processor gets the first element of the DQ. So if one of the processor completes its execution of its own threads, it can steal the threads from another process. So it gets the last element from the DQ of the another process. So and execute it. So this is the way we have to execute on this in the DQ process. That's all.